Okay, Calc Chapter 2, number 49. We're trying to find tangent line equations for this curve y. I'm going to call y also f of x. So let's write this. F of x equals 1 over x minus 1. And we want the slope of those tangent lines to be negative 1. So remember, we have slope of a function f of x at a point x equals a. That would be, so here, let's take a look. Actually, I'm going to draw a general function, not specifically 1 over x minus 1, but let's say this is your function. Then the slope at this general point right here, remember you pick, so this would be like a f of a. We pick a point near it. Ugh. Pick a point near it, call it a plus a little bit, f of a plus a little bit, and then you draw the secant line through that. So the secant line is f of a plus h minus f of a all over a plus h minus a, which is just h. And then the way to turn the secant line into the tangent line is make h turn into 0. Okay? So this is our general slope at any point a. So I can give you any x value I want, call it a, and then plug that in and I'll get my slope. And we want the slope to be negative 1. So let's work out this side here, and at the end we'll set it back equal to negative 1. So this part equals the limit as h goes to 0 and f of a plus h is plugging in a plus h for x. So it's 1 over a plus h minus 1. And then minus f of a, and f of a is 1 over a minus 1, all over h. And then the way to get rid of the extra fractions is we'll just multiply the top and bottom by all the denominators. A plus h, ooh, this pen is not working again. A plus h minus 1 times a minus 1. But then to keep the value the same, I got to divide by that too. So now, when I distribute to the numerator, when I multiply this over here, the a plus h minus 1's cancel, and I'm left with, first let me write limit, I'm left with a minus 1 for the first term. And then when I multiply the whole thing to this guy, the a minus 1's will cancel, and I'm left with a plus h minus 1. So minus a plus h minus 1 all over h times a plus h minus 1 times a minus 1. And then stuff should cancel, and basically all of your non-h terms in the numerator ought to cancel. And I've got a minus a, I've got negative 1 minus negative 1. So really I'm just left with the negative h on top here. So this is going to be limit as h goes to 0 of negative h over h a plus h minus 1, a minus 1, and the h's will cancel. And all I'm left with now is negative 1 on top. And at this point I can plug in 0 for my h, so I don't need the limit statement anymore. It's negative 1. Whoa. Negative 1 over a plus 0 minus 1 times a minus 1, which is really negative 1 over a minus 1 squared. So this is the slope of f at any point a that I want, any x value that I call a that I want. So let's, and we wanted the slope to be negative 1, so let's set it equal to negative 1. So negative 1 over a minus 1 squared is my slope at any a value that I want to plug in, and I'll set that equal to negative 1. So if I cross multiply, I'm going to get negative 1 equals negative a minus 1 all squared. And then if I FOIL out the left side, I get negative a squared, minus 2a plus 1. And then if I distribute, I'll get negative a squared plus 2a minus 1. And then if I add 1 to both sides, I get 0 equals negative a squared plus 2a. So if I factor that, I get 0 equals a parentheses, negative a plus 2. And so then a is 0, or a is negative 2. No, sorry, positive 2. A is just 2. Okay, so these are the x values. When x is 0 or x is 2, right? Because if I go back up here, the slope of f of x at the point x equals a, well, I just found out when a is 0 or a is 2, so if I combine these two things, let me shrink this down a little. So what I figured out was the slope is negative 1 when x equals 0 or x equals 2. So when x equals 0 or when x equals 2, the slope of the tangent of f equals negative 1. Okay, well, we needed the tangent line equations. So, and if you graph this thing, well, let's see, it's x minus 1, so, or it's 1 over x minus 1, so there's an asymptote at x equals 1, and then this graph looks like this. And the slope, let's see, when x is 0, we're right here. So that tangent line looks like this, and that, yeah, that has a negative slope, looks like it could be negative 1. When x equals 2, we're right over here. Well, yeah, that looks parallel. That looks about the same slope, negative 1. And I need those equations. Well, I know that this point is when x is 0, so if I plug it back into the y, I get 1 over 0 minus 1, so that's a negative 1. And then up here, if I plug in 2, which is where my other x value is, I get 1 over 2 minus 1, which is going to be 1. So then I'll call this like T1 for tangent 1 and T2 for tangent 2. Or actually, let's call this one tangent 1 and this one tangent 2 because 0 came first. So for tangent line 1, if I put it into point slope form, it's y minus negative 1, so y plus 1 equals the slope, x minus x1, which is 0. So if I simplify that a little bit, it's y plus 1 equals negative x. And then in this case, you might as well just bring that over, negative x minus 1. So that's one of the tangents. The other tangent is y minus y1 equals m x minus x1. And at this point, I just leave it in that form. You could simplify it if you wanted to get mx plus b form, but you might as well just stop there because that is the form, that is an appropriate form for the equation of a line. And if you keep going, you're just running the risk of making extra mistakes. So I hope this helps a little bit.